don't block the PowerPoint.
This meeting is
With the
being
button.
recorded.
You're good.
This?
You're fine.
Okay.
Hello, I'm a student majoring in architecture and I'm particularly focused on sustainable design. I'm also an employee at the school where I'm helping to develop and implement course curriculum focused on sustainable design and energy efficiency for architecture and interior design students, as well as professors both nationally and internationally. Next slide. Okay, cool. The item that I brought with me to represent my project is a cherry seed. I chose a cherry seed to represent my project because I believe it embodies the concept of regenerative abundance within the context of environmental sustainability, and I wanted that concept to be a guiding philosophy throughout the planning and implementation of this project. And my hope is that I'll be able to use this seed in an allegorical sense to illustrate the importance and meaning of this project. Next slide, please. Sustainability is generally defined as meeting the needs of the present without compromising the ability of future generations to meet their needs. So a sustainable process is one where we give back as many resources as we take. Next slide, please. Imagine, for instance, a jar of marbles. And imagine that every day you take 2 marbles from this jar, but give back only 1. Over time, the jar will be empty. This is an unsustainable process. Again, the sustainable process is one where by the end of the process, you've given back as many things as you've taken. So for instance, if every day you took 1 marble, you gave back the marble that you took the day before, that would be a sustainable process. However, the concept of regenerative abundance takes this a step further. In a regeneratively abundant process, for every 1 marble that you take, you give back 2. That might sound intuitively impossible, but to illustrate this in practice, I'll use the example of the cherry seed. Next slide, please. When you pluck a cherry from a cherry tree and you eat it, all that you're left with is this, the seed. But if you take the seed and you plant it, it will grow, and it will grow into a cherry tree, and with time, that seed will produce thousands upon thousands of cherries over its lifespan, each with its own seed capable of becoming a tree. Next slide. Under this model, every time you take 1, you have an opportunity to generate thousands more. This is regenerative abundance. Next slide. Currently, our relationship with the planet and the environment can be best thought of as the first example with the jar of marbles. We're taking much more than we're giving back, and it's not sustainable. The jar is increasingly running empty. The Earth is dying. Next slide. Climate scientists estimate that by the year 2030, the worst effects of climate change will be irreversible. That's only 8 years away. We will see the worst effects of climate change within our lifespans. We need to start implementing regeneratively abundant solutions now. This brings me to my project. Next slide. The leading cause of anthropogenic emissions around the world is non-renewable energies, such as fossil fuels. Fossil fuels are an unsustainable process. They're non-renewable. They take more than they give back. And in terms of how this is distributed, nearly 40% of all anthropogenic emissions globally are attributed to the building sector. This is because buildings consume the vast majority of our energy, which comes from almost entirely non-renewable sources, which again is an issue. Next slide. So to address this issue and reduce our usage of non-renewable energy at the local level, I proposed that we retrofit the campus with solar panels. Initially, I wanted to retrofit the buildings themselves with solar panels, but as I'll explain in a moment, I ran into a few issues with this plan. Next slide, please. Okay. With the work that I'm doing, I'm able to model and calculate the energy expenditure and efficiency of buildings and project this data years into the future using state-of-the-art energy analysis software called Energy Pro. This software can generate Title 24 reports, perform cost-benefit analysis for any energy system, and calculate detailed statistics on the energy efficiency of buildings, including how much CO2 they release into the atmosphere in a given period of time, depending on the design. And it can do this essentially infinitely into the future. And it can model energy systems for entire countries, actually. So short of literally installing solar panels on the campus and monitoring their effects over the course of a year, this seemed like the best means of developing a proof of concept for my project. Next slide. However, the issue that I ran into here is that in order to utilize this software and model the energy expenditure of buildings, I would need to have access to numerous construction documents, including floor plans, elevations, sections, wall details, window details, door details, and schedules. And at first, this actually didn't seem like a huge issue to me. I've dealt with building documentation in the past, and I felt confident, so I immediately began trying to gain access to these construction documents. Next slide, please. I went to the college library and I did some research. However, that yielded essentially nothing. So I instead asked the librarian if they knew where I would be able to find these documents, but they were also unable to figure out where to find the construction documents I needed after having searched all of their archives with me, and they emailed their colleagues instead. So meanwhile, as I waited for the librarian's colleagues to do what research they could and respond to the email, I reached out to someone who are referred to as RVH for the sake of anonymity. RVH is the lead coordinator for the International Center for Sustainability, a member of the school's Sustainable Development Committee, and a board member of the city's Environmental Education Consortium. Wait, next slide, sorry. A little late on my part, sorry. I was able to set up a meeting with him where we sat together and discussed the project. He was excited about the idea and offered to help in any way he could. So I requested that he provide me with some additional resources and information on what the college was doing in terms of sustainability already and where I could seek out funding should the project take off, and he did. Next slide, please. In the meantime, a couple of weeks later, the librarian's colleagues had responded to the request for campus construction documents, only to inform me that they also did not know where to access or how to access the documents. But they suggested that I reach to the Department of Administration. So I did, but about another week of waiting, they replied only to inform me that they also were unaware of where or how to access the construction documents that I needed. But fortunately, I had been doing independent research online at this point, and I determined that the construction documents should be a matter of public record under the California Public Records Act, and therefore should be accessible by making a public records request with the county clerk at City Hall. Next slide, please. So I went to City Hall and I did exactly that. I couldn't photograph myself in it, but I did take it. However, after taking an additional 2 weeks to process my request, I was informed by the city that they also did not have access to the documents I was requesting because, as it just so happens, colleges technically do not fall under the jurisdiction of the city. Next slide, please. Instead, they informed me that the only way to access the construction documents that I needed would be to contact the division of the state architect. So I did, but by this point I was nearly out of time on my project, and I still needed time for the state architect to respond to my email, and then for me to input all the information that I had from the documents into the energy analysis software, run the calculations, and generate the reports. Next slide, please. Just make sure I'm not lost. So running out of time and with limited options left, I decided to switch tactics. I began talking to some of my friends and coworkers about the project and asked them for their input. It was at this point that my friend and coworker, who are referred to as KA, suggested that rather than generating calculations for the buildings, I could simply suggest building solar canopies to cover the parking lots on the campus. This suggestion was then later echoed independently by several other friends who I spoke to, including the embedded tutor and TA for the course, who are referred to as JC, and an information technology expert who are referred to as DG. Next slide. Not only would this approach have obvious effects of producing tremendous amount of energy, of renewable energy for the campuses, and thus dramatically reducing or perhaps entirely eliminating our dependence on non-renewables, which would save the school millions upon millions of dollars over the years in the future. This would also provide shading for parking lots, which would reduce or eliminate the heat island effect and keep parked cars cool, which are both major issues in their own right. Next slide, please. I don't know if I should do this much in detail, but I'm doing it. Heat islands are urbanized areas that experience much higher temperatures than surrounding rural areas. This is because structures such as buildings, roads, and other infrastructure absorb and re-emit the sun's heat more than natural landscapes such as forests and water bodies. Next slide, please. More specifically, the darker materials have lower albedo or albedo. such as asphalt, absorb and re-emit more solar radiation at a much higher rate than lighter materials that have higher albedo. Next slide, please. Thus, the worst cases of heat islands are unshaded parking lots with massive spreads of asphalt. This is like from our campus. Furthermore, or the other one. Furthermore, solar canopies will improve the, next slide. Will improve the fuel economy of your car. When it's 80 to 100 degrees outside, the interior temperature of your car can reach a scorching 130 to 172 degrees. Running your car's air conditioning system is the main cause of reduced fuel economy in hot weather. AC can reduce conventional vehicles' fuel economy by more than 25%. Finally, the energy that's generated by solar canopies, next slide? Yes, cool. Finally, the energy that's generated by solar canopies could also be used to power charging stations for electric vehicles, which would in turn further promote less dependence on non-renewable energy. Next slide, please. To demonstrate the significance of this project, I wanted to produce a variety of 3D models of the solar canopies for the parking lots and estimate how much energy they would produce, which again is something I've done a lot in the past. But unfortunately, due to the time I spent dealing with red tape and bureaucracy and having to switch tactics so late, by this point there wasn't much time left to complete the course project, so I was unable to implement all of this. Next slide, please. However, I was able to go out in person with my friends DG and OS and hand measure one of the parking lots on campus to determine the square footage that would be available for installing solar canopies. And we were able to determine that in parking lot 3 alone, we would have a minimum of approximately 38,100 square feet if the canopies covered just the parking spaces themselves. Next slide, thank you. And an additional 12,700 square feet for a total of approximately 50,800 square feet if the canopies also cover the lanes between the parking spaces. Next slide, please. Based on numerous case studies of similarly sized campuses and parking lots installing solar canopies, this area alone of just parking lot 3 should be enough to meet most of the campus's energy requirements. And if we expanded this to some of the many other parking lots that we have on our campuses and added solar panels directly to the building themselves, there would be absolutely no doubt that we would meet all of the energy requirements for the campuses and exceed them. And we would be doing it with entirely renewable energy. Next slide, please. In summary, this project has been a bit of a learning process for me, and it's shifted and changed and developed as I learned more and ran into new barriers and limitations. But I've tried to maintain the same goal since the beginning, which was regenerative abundance. And even though I wasn't able to accomplish everything that I wanted to yet, I plan to continue pursuing that goal into the future. I learned that we have to think of change and progress as continuous processes rather than as merely discrete results. And for big changes like this, you have to break that up into smaller steps. So to me, this is still kind of just the first step. Going forward, I want to contact the Chancellor of the college and discuss the project with them directly. I want to continue communications with RVH and the Center for Sustainability, which I already have been. I want to speak to the Board of Trustees. I want to secure funding for the project and possibly work out partnerships with the Division of the State Architect and third-party energy companies who are interested in expanding renewables, such as SoCal Edison and Sunrun. I want to create 3D models of the solar canopies, like I was trying to, calculate how much energy they will produce, and last but not least, I want to finally gain access to the construction documents necessary to produce an in-depth analysis of the long-term benefits of this project, and from there, I hope that we'll be able to expand the project to include every parking lot and building in our school district. Thank you very much.